Assalamualaikum and a very good day. My name is Nur Binti. Today I would like to present about the heat transfer and pressure drop of hybrid nanofluid aluminum oxide and silicon oxide in PEMFC cooling plate. Previously my title was battery thermal management. I have to change due to lack of resources. There is no many research about the battery cooling using PETA yet. My supervisor is IR Dr. Irnil Aziz Zakaria. Okay, we will go to the introduction. Proton exchange membrane fuel cell, also known as PEMFC, is one type of fuel cell that generate electricity through electrochemical reaction between hydrogen and oxygen. The PEMFC produce heat and water as byproducts. The advantage of using PEMFC is that it has high electrical energy conversion efficiency. And then nanofluid is nanoparticles suspended in base fluids such as water, ethylene glycol, bioglycol, and etc. The nanoparticles can be categorized into four main groups that are metal base, metal oxide base, carbon base, and hybrid or mixed metal base. The one that I use for my research is hybrid or mixed metal base. The nanofluid used in PEMFC is to reduce the size of radiator in PEMFC. Bioglycol advantages are non-toxic, fluid derived from renewable sources, and it provides the 30% lower viscosity at low temperature compared to propylene glycol, which is derived from petroleum. What I can say is that bioglycol is very environmental friendly. This research is about the effect of the heat transfer, pressure drop, and another element is electric current drop by hybrid nanofluids, aluminum oxide and silicon oxide with water bioglycol in PEMFC cooling plate. Next is the problem statement that in this research are first the stability of nanofluid due to strong van der Waals interaction between nanoparticles, and the second one is the generated electricity in PEMFC will create an electrical field that polarize the cooling fluid and allowing the electricity to leak into the coolant flow. And then the objectives of this research is first to study the effect of hybrid nanofluid in terms of heat transfer and pressure drop in cooling plate of PEMFC. And then the second one is to investigate the electric current drop in cooling plate of PEMFC due to nanofluids. So for the scope of the study, we study about the proton exchange membrane fuel cell, also known as PEMFC, and we highlighted the cooling plate. And then the next one is nanofluids. The nanofluids used are aluminum oxide, silicon oxide, and water and bioglycol as base fluid. And the last one is we study about the heat transfer, pressure drop, and electric current drop. So for the literature review, there is no academic research yet about the study about the hybrid nanofluids of aluminum oxide and silicon oxide in water bioglycol mixture as base fluid. But this is the list of the article that I refer for my research. The first one is that the experimental investigation and development of new correlation for thermal conductivity and viscosity of bioglycol water-based silicon oxide nanofluids. So the nanoparticles that highlighted in this article is silicon oxide. The finding is that the 20 ratio to 80% bioglycol water mixture nanofluid have the highest thermal conductivity enhancement, about 7.2% at temperature of 70 degrees Celsius in 2.0% of volume concentration. So the next one is experimental investigation of thermal conductivity and electrical conductivity of bioglycol water mixture based aluminum oxide nanofluid. So the nanoparticles used in this article is aluminum oxide. So the finding is the bioglycol to mixture and water mixtures results showed increment about 7.5% of thermal performance compared to propylene glycol and water. The 40 to 60% of bioglycol water mixture ratio prove the maximum thermal conductivity enhancement is twice compared to 60 to 40%. So the next one is heat transfer and pressure drop characteristic of hybrid aluminum oxide and silicon oxide. The nanoparticles used is in this research article is aluminum oxide and silicon oxide. So the finding is that the pressure drop for 0.5% of aluminum oxide, silicon oxide of 10 to 90, and the 30 to 70 mixture ratio proof increment from 22 Pascal to 26 Pascal respectively. The heat transfer coefficient showed 0.5% of hybrid, 30 to 70 of aluminum oxide and silicon oxide nanofluid is the highest compared to others, which is 9.85%. And then the last one is that thermoelectrical performance of PEM fuel cell using aluminum oxide nanofluids. And the nanoparticles highlighted in this article is aluminum oxide. The electrical conductivity in 0.5% volume concentration of aluminum nanofluids in 100 to 10, which is water to ethylene glycol, is the highest compared to 60 to 40. Okay, for this methodology process, first we start and then we identify the objective and problem statement of this research. And then we do the research by referring the previous articles or journals made by the researcher that closely related to our title. And then we do the literature review by summarize up all the article or journal that we read. And then the next step is more to the software. We develop meshing for cooling plate using ANSYS, and then we do the grid independent test to search for the optimum meshing element. We have to do repeatedly until we gain the optimum meshing element, and then we do the analysis by inserting all the information needed, the density, the heat transfer coefficient, and etc. And then after we did all the analysis, we move to report writing, which is thesis. And then that's the end of the methodology process. So this is still in the methodology, but it's more to the flowchart of CFD simulation. First, we gather all the research data, and then we design the cooling plate, and then we do the surface mesh, which is lead to the grid independent test. We must do it repetitively until we gain the optimum meshing. And then the next, we insert the boundary conditions, which is fluid and or the nanofluid aluminum oxide and silicon oxide. And then we do the CFD figuration, and then we get the results by visualization. And then lastly, we obtain the CFD result analysis after putting all the elements that we need into the ANSYS software. And this is the expected result for this research, for this study. First, the expected result for heat transfer coefficient. I expected that the heat transfer coefficient will increase along the Reynolds number. And then the next one is the expected result for pressure drop. The pressure drop that expected for this research is that it will increasing along with the Reynolds number. And the lastly is that the expected result for electric current drop will be increasing as the volume concentration increase. That's all from me. Thank you. And this is my phone number and email for any questions that you need to ask. That's all from me. Thank you. Assalamualaikum.